Hello, this is Scott. Welcome back to my YouTube channel where I cover a variety of different machine learning, AI, analytics, and data science topics, and a number of platforms included. Some things are hands-on, some things are just discussions, but today it's going to be hands-on, and the platform is going to be Statistica, which is a commercial platform. So we're going to be talking about non-supervised machine learning, where we do not have a dedicated target or something that we're trying, a dependent variable that we're trying to predict. We're actually looking how data joins together, how it associates. And so we call some of these methods clustering methods, and this one is going to be a specific clustering method on agglomerative method. Sometimes joining or tree clustering is what it's called as well. And we will be getting into other clustering techniques in the next few episodes of this. But let me show you just a simple example of this. And by the way, one of the things for agglomerative type methods is it works well with small data sets. So if you have a smaller data set and you need to understand associations and patterns, and again, you don't have a target, you just want to see how things group together, this is the appropriate method for that. It's pretty visual, so let's jump into it. So in Statistica, if I'm under the data mining tab and I go to cluster, I want to go to tree clustering. Also, there is a tab here, and you can select your method. We're going to use the Ward method, the default method. And if I click OK, I need to select my variables that I'm going to use to cluster, and I get a results panel back that I can interact with. So now I have this tree clustering, and probably the most important thing, and this will show us kind of highlight what this algorithm is doing, is this dendrogram. So this dendrogram is using this multivariate space that we have, these 5 variables, and it's grouping the different car models together. So that's what we have here. Let me expand this a little bit so hopefully you can see it. We have Acura and Olds that are actually joining. Everything starts out as its own individual cluster. So we start out with 22 different clusters, the different models for the car. And then based upon the performance metrics, speed, braking, engine size, I think. Anyway, those 5 variables, and we'll look at that again in just a second. What tends to group together? So Acura and Olds, that's kind of interesting. However, Chrysler and Dodge, those are actually both Chrysler Motor products, the lines of cars that they have. We can see here that Corvette and Porsche join together down here. And those are definitely high performance cars. Eagle and Isuzu, which seems to be a special type of sports utility. Mazda, Toyota, both Japanese autos. Saab and Volvo, both European cars. And again, these are joining all based upon the 5 metrics that we have, performance metrics that we have for these cars. And then what happens is these things start with joining pairs, right? And then they start to link together. So you can see here that Mazda and Toyota were initially in a cluster, and then Buick came to join them in this next join. And then ultimately they join out, where pretty much things Audi to Ford join together, etc. So another view that we have is we have this kind of heat map tree, and we can see, oops, oh, that's not the one I want to show. The heat map, that's basically a combo for heat map and tree together, which maybe you'll find useful. Anyway, here's the 5 performance metrics here, and we can look at the link distances for these different things with the different cars. Anyway, and you can certainly play with this. just a couple more things on this. Well, one is you get to select the number of clusters that you have, and you can certainly play with that interactively. At any point that you want, you can always hit cancel, and you'll go back to the platform prior. We can look at cluster quality. So clusters 2 and then 3 here. And then, of course, that will decrease as we increase the number of clusters. So you can, again, play with the number of clusters that you have. Let's see. Anything else? Let me show you that you can get the statistics as well for all of the different clusters by variable, right? So this is, if you'll think of it as distance metrics, in a multivariate space here, you can see the performance for the different variables that you have: price, acceleration, braking, handling, etc. And again, you can also save these statistics out. So let me create a summary. Whoops, that's not the one. Maybe it's not under advanced, it's actually under here. So I can save classifications as well, and I can look at where the clusters are. So here's membership of 1, and then from here you can launch off and you can create scatter plots, you can create, any sort of graphics. You can take it into a dashboarding program or whatever with this, and then show the relationships and visualize the relationships quite well. So we'll stop there. The next time we'll pick it up again with this cluster, but we'll look at different clustering techniques. I hope you can join me.